I've done lots of veneer work in the past, like on guitars, cabinet doors, and even curved surfaces. For all those projects, I used contact cement or a billion clamps with melamine cauls. While those methods have worked, they're not the ideal way to work with veneer. So I got a vacuum press. This is supposedly the best way to put veneer on a substrate, so today I'll do some experimenting for some upcoming projects I have planned. Before I can use the vacuum press, I need to make what's called a platen. This is a base that will make sure your project remains flat and ensure proper adhesion of whatever you're trying to glue up. The platen is simple to make, but there are a few important details. For the press that I bought, the air is going to be sucked out through a hole in the platen from the bottom. So I drilled a hole and inserted what's called a platen sleeve that came with the pump, and I flush cut it so it was flush with the top surface. Now, in order for the air to actually escape the bag that this platen will go into, some shallow grooves need to be cut into the top surface, and the instructions that came with my pump said to space them about 6 to 10 inches apart. The most important thing when making these cuts is to ensure that you're cutting through the platen sleeve in both directions. I think this will make sense why when you see the pump in action. But that's basically it for the platen. I just knock down all the sharp corners so it doesn't destroy the bag, which I could roll out onto my workbench and then put the platen inside. The pump I bought came with all these fittings, so this was really quick and easy to set up. When deciding on bag size, I figured I wanted to buy once, cry once, so I got a pretty big bag. Way bigger than I needed for the projects I have coming up, but this bag comes with a second closure rod that you can place on any point in the bag to adjust the size. The instructions listed about 6 inches from the end of the platen as an ideal location. Okay, before going too crazy with making my own veneers, I just want to see if the pump works and to get the hang of the whole process, which is sandwiching veneer and a substrate between a bottom and top caul. Glue's applied to the substrate, in this case some scrap plywood, and I put a layer of parchment paper between the veneer and the caul so the glue doesn't stick to it. The bottom caul could be slightly bigger than the panel you're gluing up, but ideally the top caul should be the same size as the panel. Anyway, the whole sandwich is placed in the bag, which is sealed using the closure rod and C-channel. Then you can turn the pump on and suck out all the air. I forgot to plug in my mic here, but I think I said I'm really nervous. Anyway, when all the air is sucked out, you can see why it's important that the grooves were cut through the platen sleeve. When turning on the pump, the plastic bag pulls tightly against the top of the platen. The grooves allow all the air to be pulled out through the hose in the bottom. I let that set up for a couple hours, then opened the bag to reveal that the veneer stuck. It works. Time for some experiment. I thought it would be really cool if I could 3D print molds that I could use in the vacuum press. So I drew up this wavy patterned panel in Fusion 360, then printed it out on my Bambu Lab X1C. But later on in the video, I'm going to show you guys my newest addition, the H2D, which is a personal manufacturing hub that combines 3D printing, die cutting, and it even has a laser all in one machine. It's insane. Moving right along, I figured the molds should be double-sided to create the shape better. So I printed a top and bottom that are inverse of each other and started gluing these thin veneers together. My biggest concern here was that the wood would crack when trying to form around the curves. A way to avoid that would be to introduce heat and moisture before the glue up process. So basically, I would steam the wood and then let it dry while clamped in the 3D printed form and then glue it up. But in my mind, applying the glue to the already curved surface seems like it would be really tricky. So I wanted to see if I could just go straight to glue. I thought the 3D printed form was going to be good enough to act as a caul, so I put it in the bag without one. But I noticed a giant curve in the top after all the air was sucked out. So I quickly cut up a 1/4 inch piece of MDF to the correct size to make the top caul and placed it in the bag. I definitely heard some cracking as the air was being sucked out, so I'm slightly nervous that this is not going to work. Also, the top is bowed even after I added the top caul, so I really don't know if this is going to work, but I do see these scallops on the ends here. This was the tighter curves on this side, so I think that maybe it's working. Really not sure. I guess check back in a couple of hours and we'll see if it worked. Really hope it does because this could be really cool. It's been more than a couple hours. I got distracted by life and left it overnight. So let's open this up and see what we got. It's such a fun sound today. It totally worked, and I think it looks really cool. So it's different than carved wood because you're not cutting into the grain. So it looks like the grain is flowing over these ripples instead of carving ripples into the grain. So it's just a different look, and I think it's really cool. Now let me clean it up and see what I can get this to look like. Very happy with the results so far. So I trimmed up the ends at the miter saw and sent it through the drum sander a billion times to flatten one face. I kept it all in the mold while doing this, so it was referencing a flat face during this process. I trimmed up the edges and did some light sanding before adding on finish to get a better idea of what this could actually look like. This actually turned out better than I expected. I did not think that it was going to form inside the tight curve there. I thought I was going to need some heat or some water in order to get it to form in that tight curve. And it looks really cool. But what looks even cooler to me is the other side where you see the curves of the layers after it's sanded. So I want to try another one where I glue up a bunch of layers of different colors of wood to see what the effect is going to be. Same process as before. I glued all the thin pieces of veneer to each other before placing it in the mold and then placing the sandwich in the press. It literally feels like opening up a present every time I take something out of the bag. It's so fun. Let's see what we got here. Everything went around the curves really well. Now let's clean it up. Same as before, 1,000,001 passes through the drum sander, and this time I wanted to sand just a little bit on the wavy side to see what that could look like. It was definitely fun to see the grain pop on this one. Okay, yeah, this is pretty cool. So it's just, I love how you see the flowing of the wood there. And I think that this could be really cool to use as an accent on like a draw front or I don't know, anything like an inlay on some table. I'm really not sure. But on the other side, I didn't sand it all the way. I still left a little bit of the indentation of the curve there. And it also has the layers sanded away. So it's a combination of both. And I think that it's really cool. So like here's the first one that was like just the waves, and here's a wave with a little bit sanded away. When I compare these two though, I think I actually like the single color better. It's more subtle and I think it would just look really, really fun in a project. Like this is like whoa in your face, and this is like, oh cool, like there's something going on there. So I think I really like this. And now I'm going to try another version, but I'm a little skeptical because it's going to be like tight corners and I don't think that the wood's going to be able to form inside there, but let's see. Back in Fusion, I designed this geometric pattern, which was super satisfying to watch print, and I repeated the same glue up process. I had very low expectations from this, but I guess I was just curious to see how much wood would actually form to those points, if at all. I didn't hear any cracking, but it also didn't compress as much as I thought it was going to. I don't know. Okay. It's been 4.5 hours. Let's see if it worked. I'm very nervous about this one. It sort of worked. I was surprised as to how deep some of the indentations were without the wood cracking. So I sanded it flat on both sides of the drum sander to see what sort of pattern this would create. Yeah, this does not look good. I do not like this, but I figured that this was going to be the case with those tight corners in there. It worked really well with the curves, but the corners I figured was going to be a problem with wood, so I have another idea. Fabric. I took these little swatches of different colored fabric and used my hands to spread some epoxy in between the layers. Super messy, but also kind of fun. I don't work with epoxy often, so I was worried about the open time. I had no idea when this was going to start setting up, so I was rushing like crazy. I let that set up overnight, then I got to open up the present. But, uh-oh, something was wrong. Okay, it seems like this is stuck. Oh, I think I might have a problem here. I think the form is like permanently stuck because of the epoxy. I didn't think that epoxy stuck to PTG, but I could be wrong. Let me see if I can pry this open. You know what I think I'm gonna do? I'm gonna cut off the sides here so I have better access to the edges of this because it's like completely fused together with epoxy here. In retrospect, I should have placed a barrier like packing tape or parchment paper between the mold and the fabric. I put some on the outside of my sandwich because I didn't want epoxy getting on my brand new vacuum bag, but I could have avoided all this prying by thinking a little smarter. Lesson learned for the next time. Finally, I got all of it off and it kind of looks like a chocolate bar before sending it through the drum sander. After each pass though, it was really cool to see the design take shape. I pried off the other side, which looks like an even more delicious chocolate bar because it didn't have those air bubbles at the points. And this just looks so fun. Every pass revealed a new pattern, and at this point, I thought it could be cool to fill those voids with epoxy for an interesting look, but I kept on sanding to see what sort of pattern I could get when all the voids were sanded away. To finish this for a project, I would probably do a flood coat with more epoxy, but I didn't want to mix up anymore, so I used some thin CA glue to mimic the look of putting on a finish coat. This is super fun and it's really cool looking, but to be honest, I would never put anything like this in any of my furniture builds. It's just not my aesthetic, but I would possibly do something like this as like an inlay on a guitar. Like that would be really cool. So maybe one day I could do that, but for now, it was just really fun to experiment with making these forms with 3D printing and the vacuum press. I just had this idea, I had to get it out of my head, and now I could focus on using the vacuum press for what I actually got it for, and that's saving some money by making my own hardwood veneered plywood panels for upcoming projects. When making veneer, you want to aim for a finished dimension that's thinner than an 1/8 inch. 3/32 is usually my goal thickness. This is my first time making veneers using this bandsaw, so I set the fence so it's cutting strips that are ever so slightly bigger than an 1/8 here. If you don't have a bandsaw, you can also resaw at the table saw using a thin ripping jig. The one I'm using here was made using all 3 functions of the new Bambu Lab H2D printer. I found this file on MakerWorld and quickly printed all the parts, then assembled it with the required hardware, and it works better with a ruler to set it up accurately, so I drew one up and used the cutting module to cut it out as a sticker. Now I need to set it against the blade to mark where 0 is, and it looks like the designer of this jig just used a pen or a marker on his, but thanks to Bambu Lab, I have a laser now. So I laser cut a small triangle out of acrylic and glued it to the 0 mark on the jig. The acrylic triangle stays on the base as you adjust the top to the measurement you need and cut. As you can see, this is a super accurate way to make repeatable, thin strips at the table saw. I wanted to play a bit more with the features of this personal manufacturing hub. So I laser cut an image on a cutting board and look at how clean that looks. I was blown away by the quality. Then switched over to the cutting module to make a perfect vinyl template for a monogram that I could carve with a router. I think this adds a little more of a handmade feel to this gift. In the past, I've done this with using printer paper and spray adhesive. Die cutting vinyl that you can easily remove makes this task so much easier. After finishing, I took advantage of the dual nozzles to print my own custom cutting board feet. Yes, this printer has 2 nozzles, so I can print one object with 2 different types of filament. These are a combination of hard PETG and soft TPU, which will make them grip onto a countertop. Being able to mix materials in one print is a game changer. I try to design my products so they don't need support material as they're printing, but I see this being super useful next time I need to enable supports. It's just so cool that this one machine is able to do all these different fabrication processes that you can use to complete a single project. It really is the best all-in-one DIY powerhouse to have in your shop, and its precision cannot be beat. TPU is notoriously hard to print, and I printed a whole TPU shoe. like a real flexible shoe that's comfortable and you can walk in. The quality of this print was just mind blowing to me. Look at how clean this is. I'm having so much fun experimenting with everything this machine can do. I have so many ideas for upcoming projects. So huge thanks to Bamboo Lad for sponsoring this video. Back to the veneer. All these boards are looking really nice, except for the last one. When I look at the back of the last one, it looks like a wedge. So even though my blade was square and my fence was completely square, something went awry and I forgot. I saw a tip a few years ago from Philip Morley where you put the board in one direction and then to do the next cut, you flip the board end for end and then you cut it that way. And that way it'll even out any slight inconsistencies in your setup. So I'm going to try to remember to do that when I'm actually doing this for a project, but I'm going to clean these up anyway at the drum sander. One thing I need to keep an eye on are these edges. There was a lot of tear out on the bottom of the cut because the throat plate has a big gap. So I need to see if adding a zero clearance throat plate will be necessary if that tear out doesn't get cleaned up here. Now, why am I going through all this trouble to make my own veneers? Well, I'm building a project soon where I would need at least 100 board feet of 8-quarter walnut, and I priced that out and it would be around $2,000. I didn't want to spend that kind of money on material, so I figured this would be a good project for a vacuum press because I can get the most out of an expensive material, like only making it the show face of the project. I could opt to use hardwood veneer plywood that you can already purchase, but I've used the stuff and I'm not a fan. The veneer is so thin, I've sanded through it way more times than I'd like to admit. And I've yet to purchase a piece of walnut plywood that I actually like the grain pattern on. By making my own veneer, I get to control how the grain looks on my piece, which will lead to a better looking end product. Besides for saving money on raw materials, veneered plywood is actually more stable than hardwood. So for some projects, it's better than using hardwood. I know people hear the word veneer and that translates to fake in their minds, so they think it's low quality. But when done right, veneer furniture can be superior than hardwood. So how do you do it right? The thickness here matters. You may think the thicker the better, but that's not the case. Once you get over the 1/8-inch mark, the wood starts to act like solid wood again, and it could move with the seasons, which might create cracks in your project. There seems to be a lot of debate on the interwebs about the perfect thickness, but 3/32 is a common thickness that people use, and it's what I've done in the past that works for me. Since this was just an experiment, I wasn't aiming for a thickness here. I wanted to see what the planks would end up being after they were all cleaned up with the settings that I had on my bandsaw. It was really hard for me not to check the thickness of the pieces after each pass, but I really wanted to just see how big they would get just like completely cleaning them up, like not aiming for a target thickness. And whoa, okay. I got 7/64 on both sides there. 7/64. 7/64. All right, completely even all around. 7/64 is slightly larger than 3/32, which is my target thickness. And that's great. It's going to leave me some room for sanding. So now I'm going to talk about a few different ways that you could go about matching these boards or gluing them together to make it look like one solid board. The first way is called slit matched, where you just lay the boards next to each other in the order that they were cut. This method is nice when you have straight grain. This board had way too much character for this to look good. It just looks really weird here. So another method is to do a book match where every other piece is flipped over, which creates a really cool design because of the unique character on the board. I'll go with the book match here, but I think on my project that I'm planning this for, I'm going to try and do a random match, meaning I'm going to try and make it look like it was separate boards glued together. We'll see. Even though this piece was square before resawing, the edges don't mate up perfectly. So I take 2 pieces at a time, fold them in half, and run them over the jointer one time to create a seamless joint between the parts. Looks like the tear out on the initial cuts wasn't a problem at all, so I won't need to make a zero clearance insert. And I prefer to do this actually with a hand plane, but my bench is covered with the veneer bag, so this works too. Before gluing these veneers together, I need to prep the substrate that they'll be glued to. I want the final board to be thicker than one piece of plywood, so I glue two pieces together and set that off to dry in the press. It's so awesome that I can make super flat panels like this without a billion clamps. But for some reason, the C channel wasn't going on the closure bar as easily as it was before, so I needed to use a clamp to seat it in position. When this bag came, there was like a powdery substance on it that helped it glide over the sticky plastic a little bit better. And that powder, I guess, was rubbing off, so it was super difficult. While making your own shop sewn veneer saves money and gives you more freedom with grain pattern, it does take a lot of time. I start with the show face first and place tape across the joint, pulling it as I go. You can see this creates a good tension on the boards, acting like a clamp. Then, for even more strength, I add one long strip of tape along the joint and repeat the process for the other seams. Here I'm experimenting with putting the tape on top of the previously laid down tape so it'll be easier to lift up after. Make sure the tape is really well adhered to the panels and flip it over to glue it up. I put a small bead of glue in between the boards and scrape away all the squeeze out before putting on some more tape that will really close up these joints. I guess I didn't mention this. I'm making two different panels here because when you veneer a piece, you need to veneer both sides of it. If you only do one side, the whole panel may warp due to uneven moisture absorption into the panel. This would be another great way to save money though. So you can use your nice expensive wood on the show face and then use a secondary, less expensive wood on the bottom. Another benefit to making your own veneered panels is that you can edge band before the veneer goes on, which I think makes for a more seamless look. I waited about a half hour for the glue to set up here just to keep moving along and took off all the tape. I used to leave the tape on the show face when I would clamp between the cauls, but the tape was so hard to get off that way, so I think it's better to take it off beforehand. When I'm actually doing this for a project, I have an idea. That first strip of tape, I'm going to make a little loop so this is easier to pick up, but it's really easy to lift up all the two other pieces because they're layered on top. So that was definitely a good idea. Now I just got to make a loop on that first piece to make it easier to lift up. At this point, I just use a card scraper to clean up the dried glue on the side that will be glued to the plywood. And as you saw before, I was having a lot of trouble getting this on the bag to close it. So before I glue up the panel, I want to maybe put some chalk on here to make it go a little bit smoother so there's less friction. I'm just going to break off a piece of here and like smudge it in and maybe put it on the plastic. I couldn't find any information online about what the proper thing to use was, but seems like chalk could work. Let's see. Okay, let's test this out. I did a lot of research on glues before I started this process and settled on one called Unibond 1. I found this on the website where I purchased my vacuum press. And there's also a lot of really detailed videos on their website explaining the whole veneering process. And there is one that explains the difference between all the glues that you can use. This is my first time using this glue, so that's another reason why I needed to do this whole experiment. With the foam roller, I was able to really quickly lay out all the glue, and I put tape on all the pieces to make sure they don't move around too much. Then I sandwiched the whole thing between cauls before putting it in the vacuum press. I also took that chalk from earlier and rubbed it on the plastic to try to reduce the friction of the C-channel. Yeah, it totally worked. I don't know what powdery substance they shipped it with, but this works fine. Again, so glad I'm doing these experiments before working on my real project, so those glue ups will be a little less stressful. The sound is so fun every time. So since this whole thing was an experiment for an upcoming project, I'm going to experiment even further. That project is going to be a mitered box. So I'm going to take this panel and cut it up to make a box and see what the scenes look like. Also, moving forward, I may need to put this in a different place in my shop because I did not like not having a bench while it was out. Got my workbench back. Okay, so I jointed one edge of the panel, then trimmed it to width with the table saw and cut it into 4 pieces at the miter saw. I'm honestly still debating what method I'm going to use to miter these on the real project. The ideal method for me would be to use a crosscut sled, but the project is going to be 1.5 inches thick, so the blade won't cut all the way through when tilted to 45 degrees on a sled. So I tested this way. I just kept adjusting the fence until I saw that the blade was cutting at the edge of the material and then cut both sides. I actually don't even think that this is going to work for my project thinking about it now, since I'm going to need to cut longer panels. Well, we'll see. Gluing up miters is always fun. Just tape up all the corners, spread some glue in there, and roll it up. I was curious as to how much money I would be saving by doing this process. So I measured this board before I milled it up. It was 39 by 3 by an inch and a half. The panel I created ended up being 12 and a half inches wide. So I entered all this info into a board foot calculator, and the piece I started out with was 1.6 board feet. The new panel I created was 6.8 board feet. I asked ChatGPT what the average price of a quarter walnut is, and it gave me a whole ridiculous Megillah. One sentence answer, please. Okay, $10 to $20. That tracks. My local place lists a quarter walnut at around 15, so let's go with that. With those numbers, the board I started out with cost around $24, and the board I created would have cost $102 to buy. Obviously, there's the cost of the vacuum press, the price of the plywood, glue, tape, and probably most importantly, my time. But I legit feel like I just unlocked a superpower by efficiently being able to stretch expensive materials further. Using the method with melamine cauls and clamps like I've done in the past can only get you a panel so big, and getting those clamps on is insanely stressful. Getting this vacuum press really opened up a lot of creative freedom for me, and I can't wait to use it on my future projects. This turned out great. I'm so glad that I did all this experimenting, because I think it's been like 4 years since I did any sort of veneer work, so I definitely needed the practice. And even with minimal clamping, these miters look great. The grain wrap worked perfectly, and the front edge banding looks seamless. Like, it looks like this could really be the edge of this board. I knocked down the corners just a little bit, but this is where you have more freedom when making your own veneers. If you knock down the store-bought plywood this much, you would sand right through the paper-thin veneers. I really like this whole vacuum press process. Like, it feels legit, but there's two things that I kept forgetting. The cauls, I kept forgetting that I need to make them. So I'm saying this now to remind myself, go purchase quarter-inch MDF. I also kept forgetting to knock down the corners on the call so they didn't puncture the bag. So I really hope that I remember to do that moving forward. All right, I think I'm ready to start working on the real thing now. So I hope you guys enjoyed coming along with me as I did these experiments. I actually typically do this stuff off camera, so I hope this was interesting for some of you. Thanks so much for watching, and I will see you on the next one.